Okay, hello everyone, it's Salar and we are in part 44 of our tutorial, a tutorial to writing a real-time operating system. In previous part, I gave you some information about priority lists in a real-time operating system. And I showed you what's the structure of priority lists and ready lists in our real-time operating system. But as I said, in this part, I want to start to talking about system call instruction in our real-time operating system, okay? System call structure. How we can call a system call in our real-time operating system. For example, create new thread. Create new thread is a system call. How we can say to operating system to create a new thread. Create new thread is a function that called system call. By using a system call, you can receive some services from your real-time operating system. Okay, but before starting to talking about system call structure in real-time operating system, I want to give you some information about SVC exception, an exception in ARM core processor, ARM Cortex-M processor, another exception in Core Cortex-M processor, and exclusive access in ARM processor or atomic access, okay? And we will utilize these facilities of ARM Cortex-M processor to implement a real-time operating system. These facilities is so important to us, okay? And by using of these facilities, we can implement system call of a real-time operating system. Okay, so first let's talk about SVC exception or SVC interrupt. Supervisor call. SVC stands for supervisor call. SVC exception. As I said, SVC or supervisor call is a core interrupt or exception. I said in ARM processor, ARM Cortex-M processor, core interrupt called exception. Okay, and all of kernel codes in our RTOS will run in this exception. Okay, so this exception is so important to us. I will a lot of information about this sentence in future parts. Okay, but in this time I want to show you what is SVC exception and how you can use this exception in your code and in your program. Okay, how can I jump to SVC handler? How can I jump to SVC handler? By this instruction, by using of this instruction in your code. SVC and a number, an immediate number between 0 to 255. For example, SVC 0, SVC 1, or other numbers between 0 to 255. Okay, and in your SVC handler, you can find what was this number in instruction. But this number in implementation of my real-time operating system is not important. If you want to know how you can find this number in SVC handler, you can search for that on internet. Okay, it's easy, and I don't give you information about that in my tutorial because it's not important to us, and always I use SVC 0 in my real-time operating system. But there is an important point. You can't use this instruction in an interrupt or exception that has higher or equal priority. I said, for example, in Cortex-M processor, you have 256 levels of priority, 256 implementable levels, okay? For example, I said in my microcontroller on my board, I just have 16 implementable interrupt priority levels, okay? So you can't use this instruction in an interrupt or exception that has higher or equal priority. I said In ARM processor, in ARM Cortex-M processor, a smaller priority means higher priority. Okay, for example, an interrupt with priority 0 has highest priority, for example, in my microcontroller, and an interrupt with 15 priority has lowest priority. Okay, for example, if the priority of SVC is 10 in your microcontroller, you can't use this instruction SVC in an interrupt or exception that has higher priority. In other interrupt, for example, interrupt of timer. So for example, in handler of timer interrupt, that priority of this interrupt is 5, you can't use SVC. Okay, you can't use SVC. If you use that, you will have a hard fault in your processor. Okay, so this note is so important. You can't use this instruction in an interrupt or exception that has higher or equal priority than SVC. But I want to give you some detail about our operating system. In our real-time operating system, systematic priority will be 0, highest programmable priority. SVC priority is number of interrupt priority level minus 2. For example, in my board, or for example in another microcontroller, it's a microcontroller from NXP. Okay, in this 2 microcontroller, you have just 16 levels of priority, 16 levels just implemented. Okay, the NVIC prio bits is 4, the number of level is 2 to the power of this number. In these 2, for example, it's an example, it's not related to all of microcontrollers. For example, in one microcontroller you might have 8 levels of priority. Okay, but in my microcontroller I have 16 levels of priority. To port my RTOS to my microcontroller, I need to set priority of systematic as 0, SVC priority, number of interrupt priority levels 16 minus 2 equal to 14, and PendSV priority is 15, number of interrupt priority levels minus 1. We will use these details to implement our real-time operating system. Okay, and I use system call SVC and PendSV to implement my real-time operating system, especially these 2 interrupts and exception to implement system call. Okay, here was some details about our real-time operating system, and I will return to these details in future parts. Okay, but let's see an example about SVC interrupt in Eclipse. Okay, here is an example, and as I said, by using this instruction and an immediate value, you can jump to SVC handler. Okay, if the processor runs this instruction, immediately jump to SVC handler. As you can see in this assembly, now my processor wants to run this assembly instruction. By using of this block, you can embed your assembly instructions in your C code. Okay, as you can see in this assembly form, I have SVC 0, and if I run this line, the processor immediately jumps to SVC handler. System supervisor call. Okay, and after running this handler, return to main function. Okay, I will use this instruction and this handler to implement system call in my real-time operating system in future parts. So let's go back to our slides and talk about other things. Now let's talk about exclusive or atomic access in a processor or in ARM Cortex-M processor. To find out what's exclusive or atomic access, let's inspect this example. Assume in your code you have a global variable, okay, and the value of global variable is 1, and you want to run this if block. What is this if block? It says if the value of global variable is 1, you can decrease the value of global variable in the block. Okay, if global variable is 1 is equal to 1, global variable minus. But assume that the processor is running your code. First, check the value of global variable. The value of global variable is 1. But before running this line of code, suddenly you have an interrupt or exception. Okay, and jump to an interrupt handler. And in this interrupt handler, the processor put the value of 0 in global variable and return back to your code, to your function. Now, in this part, in this point, before running global variable, this condition, the condition of this if block is no longer fulfilled and is no longer met because the value of global variable has been changed to 0, and you mustn't do this line. Now you can't do this line because the value of global variable is 0, but the processor doesn't know, because first check, after that jump to an interrupt, break code from here, breaks code from here. Okay, and the code between this checking and writing value has been broken by an exception or interrupt. So how we can solve this problem? We need to know if my code between this checking and this writing has been broken, I mustn't write new value in global variable, and I can't write this value, and if I write this value, I have an error in my code. So how we can solve this problem? Before talking about exclusive access in ARM processor, let's talk about a process: read, modify, write. You need to have this process in your code atomic and unsplittable. Another time you have a global variable, the value is 10. In your function, you first read the value of global variable in a local variable. Read, modify the value, and write new value in global variable. Okay, I need to have this block of code atomic, or I need to have access to this global variable exclusive. I need to have exclusive access, and if my code has been broken between this read and this write, for example, jump to interrupt handler and return from interrupt handler, I mustn't write new value in global variable. Okay, I need to have this phenomena in my code. So how we can implement this phenomena in my code? By using up these two instructions, load exclusive and store exclusive. When you write a value from an address in your memory to a register by this instruction, you start an exclusive access. Okay? Now, if before this store instruction you have a break in your code, if you have a break, for example, jump to exception or interrupt, okay, your processor doesn't write new value, changed value in memory another time. Okay, so if you have a break between your code, first you read from an address in your register RT, increase value of RT by 1. Now you want to write the value of RT in RN address. If you don't have, I repeat that, if you don't have break, your processor write this value to this address and put 0 in this register, and means the writing and your process is successful. But if you have an interrupt between this load and this store, your processor will not write value of this register to this address and return 1, and it means the process has been failed. Okay, so in this way I can solve my problem, and by using these two instructions I can have an atomic block in my code. If your code has been broken, you can't write the value in the address. Let's see an example about atomic access. Okay, here is example. I have a global variable. I want to use this interrupt to create a break in an atomic process, and I have main function. Okay, in my main function I have a local variable to read the value of global variable. I have a result, the defined variable to read the result of a store exclusive. Okay, by using of load exclusive word 32-bit, you can read a variable exclusively, okay, and start an atomic part, okay, and use this CMSIS function instead of store exclusive. Okay, use these two CMSIS function instead of instructions. Okay, in CMSIS, read global variable, write a value to global variable, and return the result. The result, as you can see here, let's see, when the result is 0, writing is successful. When the result is 1, writing is failed, and you have a break in your atomic part. You had a break in your atomic part. Okay, let's debug this project. So here I'm in debug perspective. First load exclusive and start an atomic part. Okay, read the value of global variable in I. The value is 10. Value of global variable is 10. Modify the local variable and write the result. Modify to 11 and write the result in global variable. As you can see, the value of global variable now is 10, is 10, but if you run store exclusively, the result is 0, means the exclusive access was successful and the value of global variable is 11. Right, read, modify, and write. But let's see another example and break the code from this part between load and store. Now I want to break my atomic access between load and store by jumping to SVC handler by running this line. Okay, yeah, I said by writing a 1 in bit 28 of this register, you can jump to SVC handler. Okay, now let's see another time the result of this example. Okay, in this time the value of global variable is 10. Okay, run load exclusive and start an atomic part, but as you can see, read the value of 10 in I. Let's break the atomic part by jumping to SVC handler. Run this line, jump to next line, but your processor doesn't find this line, and jump to SVC handler. Now I've broken the atomic part. Let's do return to our code. Okay, now I++ increase the local variable. You see I is 11. Now I want to write I in global variable, but before this store I've broken the atomic part. Now if you run store exclusive, now in this time result is 1. Writing was failed, and the value of global variable another time is 10 and have not been changed to 11. Okay, when you break the atomic part, you can't write new value in global variable or any variable, okay, any other variable, okay, because I have a break between load and store. Okay, in this way I can have an atomic part in my code. Here is an atomic part, started from load and ended by this instruction, store. Okay, here was exclusive access in ARM processor, and I will use SVC exception and exclusive access to implement system call in my real-time operating system. I will continue talking about system call in next part, and I see you in the next part. Thank you very much to see me. Thank you very much.